morning to all. Today we will discuss module 3 in the engineering tribology subject. The topic is called as a lubrication and the lubrication regimes. Module 3 consists of what we will call we will be having the brief introduction about what is the lubrication and the lubrication regimes, and we will have the differentiation between the hydrodynamic and hydrostatic lubrications and the various theories of lubrication and the lubricating system. These are the concepts we are going to discuss in this third unit. A lubrication is nothing but a substance which is inserted between two surfaces which are in relative motion in order to reduce friction, wear, and the heat generated during the parts. The examples of the lubricating system is the sleeve bearing and the shaft, and an anti-friction bearing and the cam and followers. You can see here lubrication is nothing but any substance that when inserted between the moving surfaces accomplishes these purposes. These purposes are nothing but reduction of friction, reduction of wear, and the heating of the machine that moves relative to each other. The difference between hydrodynamic and hydrostatic lubrication is nothing but, in general, dynamic is nothing but calculation of the force with the magnitude, and the static is nothing but calculation of a force of a particles without considering the magnitude of the force. Okay, now we will see what is hydrodynamic lubrication and what is hydrostatic lubrication. Okay, in simple, lubrication is nothing but application of a substance between the two metal surfaces in order to reduce the friction, wear, and the heat generation. Okay, in hydrodynamic lubrication, the oil film is formed by the relative motion of the two surfaces, whereas in hydrostatic lubrication, the oil film is formed by the externally pressurized oil. Next, hydrodynamic lubrication means that load carrying surface of bearings are separated by relatively thick film of lubricant so as to prevent the metal to metal contact, and the stability thus obtained can be explained by the laws of fluid mechanics. Hydrodynamic lubrication is also called as full film or fueled lubrication. Hydrodynamic lubrication is nothing but a thick film lubrication. In thick film lubrication is nothing but there is a large amount of clearance will be there between the two mating surfaces or two surfaces which are in contact. That large amount of clearance is filled with the help of a fluid. So the fluid will be available in the full amount. So because of that reason, it is called as a full film lubrication or fluid film lubrication. Next, coming to the hydrostatic lubrication. Hydrostatic lubrication is also called as what we'll call externally pressurized lubrication. Externally pressurized lubrication is obtained by introducing the lubricant, which is sometimes air or water into the load bearing area at high pressure enough to separate the surfaces with relative thick film of lubricant. So hydrodynamic lubrication, the kind of lubrication does not require motion of relative to each other. Okay, in hydrostatic lubrication, lubricant is supplied in between the surfaces with the help of pressure. In hydrostatic pressure, mostly it will be in the liquid form, not semi-liquid form like a grease. It will be in the form of liquid like what we will call water or oil. Okay, here relative motion is not required because we are pressurizing the liquid between the surfaces. Okay, in simple, hydrodynamic lubrication is nothing but, in hydrodynamic lubrication, oil film is formed by the relative motion of the parts, whereas in hydrostatic lubrication, oil film is formed by the application of a pressurized fluid in between the surfaces. This is the major differences between the hydrodynamic and hydrostatic lubrication. Next, we'll see what are the lubrication regimes. Lubrication regimes are nothing but sliding friction is significantly reduced by addition of lubricant between the rubbing surfaces. Sliding friction is generally reduced by the application of lubrication between the two rubbing surfaces or two sliding surfaces. Engine bearings are lubricated by engine oils constantly supplied in sufficient amount to the bearing surfaces. Sufficient amount to the bearing surfaces. Lubricating friction is characterized by the presence of thin film of the pressurized lubricant between the surface of bearing and the journal. Lubricated friction is characterized or functioned in the presence of the pressurized lubricant between the bearing surface and the journal. The ratio of squeeze film, nothing but the oil film, to the thickness of the surface roughness determine the type of lubrication regime. You can see lubrication regime is determined by the ratio of H by surface roughness. Okay. Based upon this ratio, we will see what are the different types of the regimes are available. See, if H is less than RA, nothing but thickness is less than the roughness of that one, then we will call as a boundary lubrication. Boundary lubrication. In boundary lubrication, a constant contact between the frictional surfaces at the high surface points occurs at the boundary lubrication. A constant contact will be available at the surface points. Okay. This regime is the most undesirable since it is characterized by high coefficient of friction. Boundary lubrication regime is undesirable because it is characterized by high coefficient of friction and increased wear is possible here, and possibility of seizure between the journal and the bearing material is available in this one. Non-uniform distribution of bearing load are the one of the more reason will occur at the boundary lubrication. Okay, boundary lubrication occurs when the thickness is less than surface roughness. Okay, this phenomena, boundary lubrication regime, is undesirable because it has a high coefficient of friction and the more increased wear and the seizure possibility of seizure between the bearing and journal materials, and the non-uniform distribution of load take place here. Okay, very severe engine bearing failures can be caused by the boundary lubrication. During the boundary lubrication, engine bearing failures will be occurring. Okay, next one, condition for the boundary lubrication are really mainly at low speed friction and high loads. Okay, boundary lubrication generally occurs at low speed friction and the high loads. When the speed is very less and the load is high, very high, in such conditions we will call it as a boundary lubrication. Externally, extreme pressure additives in the lubricant prevent seizure conditions caused by the metal to metal contact between the parts in the boundary lubrication regimes. Okay, extreme pressure additives. Additives are nothing but the particles which can be added to the lubricant in order to get the desired properties. Okay, here if you are able to add the extreme pressure additive to the lubricant, then it is able to avoid the metal to metal contact between the surfaces in contact. In such conditions, we will be having the boundary lubrication. In simple, boundary lubrication will occur when the thickness is less than the surface roughness of the particles. This boundary lubrication is undesirable regime because here high friction loss will take place, more wear will take place, and there is a possibility of engine seizing, and the non-uniform distribution of the load will take place. Okay. The conditions for the boundary lubrications are low speed frictions and the high loads, and if we are able to add the extreme pressure additives to the lubricant, there is a chance to prevent what we will call direct seizure of the engine parts which are in contact with each other. Okay. Now we will try to see the next regime, mixed lubrication. Mixed lubrication. Here, thickness is approximately equal to the roughness. This is an intermediate or intermittent contact between the friction surfaces at a few surface points occur at the mixed lubrication. Mixed lubrication is the intermediate region between boundary lubrication and the hydrodynamic friction. Mixed lubrication is between intermediate region between boundary lubrication and the hydrodynamic friction. High speed rotations at relatively low bearing loads results in the hydrodynamic friction. Okay. Now you can see the hydrodynamic lubrication here. Okay. Mixed lubrication is nothing but in between the boundary lubrication and the hydrodynamic lubrication. Now we will try to discuss hydrodynamic lubrication. In earlier slide also we have discussed, in hydrodynamic lubrication, oil film is formed by the relative motion between the surfaces in contact. Here we will try to see in depthly. Here in hydrodynamic lubrication, thickness is greater than what we will call surface roughness. In hydrodynamic lubrication, high speed rotation at relatively low bearing loads results in the hydrodynamic friction. It is characterized by oil film between the rubbing surfaces. No contact between the surfaces occurs in the hydrodynamic lubrication. The squeeze film keeps the surface of bearing and the shaft apart due to the force called hydrodynamic lift generated by the lubricating squeeze through the convergent gap between the eccentric journal and the bearing. Bearing working under the condition of hydrodynamic lubrication are called as a hydrodynamic journal bearings. Okay. Here, hydrodynamic journal bearings are nothing but the bearings which are working under the condition of hydrodynamic lubrication. In hydrodynamic lubrication is nothing but you will be having the oil film between the contact surfaces. You can see the boundary pictorial representation of the various regimes of the lubrication. First one, you can see the boundary lubrication, and second one is the mixed lubrication. You can see the hydrodynamic lubrication here. Here, coefficient of friction will be high in the boundary lubrication, and it will be reduced in the mixed lubrication, and it will be very much less in the hydrodynamic lubrication. Here you can see the bearing parameter, okay, efficiency into the speed and divided by density into area into the velocity. Okay, all these parameters are mainly depends upon Strebech curve. This we will call as a Strebech curve. Lubrication regimes are mainly depends upon the what we will call Strebech curve. Here you can see the boundary lubrication. The distance bit in boundary lubrication, you can see this space, the contact will be, there are the more chances of contact will be there. Where compared to the mixed lubrication, you can see the gap over here. You can see this gap will be, some possible gap will be there. Whereas in hydrodynamic lubrication, you have the plenty of the gap over here. Okay. So when the lubrication is more, you will be having the less amount of the friction. You can see this is a graph plotted upon the y-axis coefficient of friction and the x-axis bearing parameter. Okay. Now you can see here the three different regimes are clearly distinguished in the Strebech curve. You can see in the previous figure. We demonstrate that relationship between the coefficient of friction and the bearing parameters. Okay, the stability of different lubrication regimes may be explained by the means of Strebech curve. As the temperature increase due to the heat generated by the friction, causes the drop of lubricant viscosity and the bearing parameter. Okay, according to the Seebeck curve, decrease of the bearing parameter in the mixed regime causes increase of coefficient of friction followed by the further temperature rise and the consequent increase of coefficient of friction. Thus, the mixed lubrication is unstable. In case of bearing parameter due to the temperature rise, lower viscosity in hydrodynamic regime of lubrication causes the coefficient of friction to drop with the consequent decrease of the temperature and the system correct itself. Thus, the hydrodynamic lubrication is stable. Okay, according to the what we'll call Seebeck curve, mixed lubrication is unstable and the hydrodynamic lubrication is the stable one. You can see the over here. Mixed lubrication is unstable and the hydrodynamic lubrication is the stable one. Now see here, mixed lubrication is nothing but, hydrodynamic lubrication is nothing but theoretical analysis of hydrodynamic lubrication was carried out by Osborne Reynolds. The equation results from the analysis have served the basis for designing the hydrodynamic lubricated bearing. In simple, hydrodynamic depends upon the Reynolds equation. Following assumptions were made in the Reynolds equation that lubricating fluid is a Newtonian fluid and the fluid flow is a laminar and the shear stress between the flow layer is proportional to the velocity gradient in the direction perpendicular to the flow. That is nothing but Newton's law of viscosity. Okay, tau is equal to efficiency into dou v by dou y. This is equation where n is the dynamic viscosity of the oil, v is the linear velocity of laminar layer, and y is the axis perpendicular to the flow direction. The inertia forces result from the accelerated movement of the flow. Lubricants are neglected and the lubricating fluid is assumed to be incompressible and the pressure of the fluid P is constant in direction perpendicular to the laminar flow. Okay, this is nothing but dP by dy equal to 0. The viscosity of the fluid is constant throughout the lubricating film, considering the equilibrium of unit volume in the lubricating film. All these are the assumptions which are assumed in the Reynolds equation. Hydrodynamic lubrication is also called as a fluid film lubrication, thick film lubrication, or flooded lubrication. There are three different names for hydrodynamic lubrication: fluid film lubrication, thick film lubrication, and the flooded lubrication. Maybe there are the three different names. The main criteria is nothing but there will be more gap between the surfaces, so more amount of the lubricant will be present in between the surfaces. A thick film lubricant is interposed between the surfaces of bodies in the relative motion. There has to be pressure buildup in the film due to the relative motion of the surfaces. Fluid friction is substitute for a sliding friction. Try to see the word. Fluid friction is substituted for the sliding friction. Coefficient of friction is decreased here, prevalent in general and thrust bearings. Here in aerodynamic bearings, coefficient of friction will be decreased when the journals and the thrust bearings are used. Now you can see the explanation of the hydrodynamic general bearing between the parallel surfaces. You can see the plate 1 and plate 2, and the shear force F is acting at a distance of y from the base, and you can see the velocity profile over there, and the direction of the motion of the tap plate will be here. You can see with the help of the red arrow symbol here. The top layer of the fluid moves with the same velocity as the plate. Okay, now you can see the yellow color, that is nothing but the lubricant. The velocity of the bottom plate will be 0 and area A is of the plate. Okay, there is no pressure buildup in the fluid due to the relative motion. It may remain constant throughout, the influenced only by the load, and as the load increases, the surfaces are pushed towards each other until they are like to touch. As the load increases, the surfaces are pushed towards each other until they are likely to touch. Now see, hydrodynamic lubrication, you can have the oil wedge is nothing but whatever the yellow color you can see is nothing but oil wedge, and the drag forces you can see, drag force it is horizontally, and the lift force in the vertical, and the top surface is moving towards downside. Now, force are normal to the surfaces, and the bottom surface you can see the surface are inclined to each other, thereby compressing the fluid as it flows. Okay, the surface are inclined to each other and it is compressing when it is moving towards each other, and this lead to the pressure buildup that tends to force the surface apart. The larger loads can be carried. Now see here, hydrodynamic theory in the journal bearings. You can see the journal bearing over here. The shaft or journal, you can see the blue color, and the bearing is nothing but this one, and the oil wedge is nothing but you can see the yellow in color. Oil wedge forms between the shaft and the bearing due to them not being concentric. If it is concentric, there is a no chance of what we call formation of oil film. Here concentric is not being there, because of that reason oil film is formed. Now you can see the velocity and pressure distribution. You can see the diverging edge is nothing but the yellow color. You can see the bottom surface and the top surface, and the pressure distribution is here, and the velocity profile is parabolic in curve. Here you can see, okay, velocity profile at the inlet is parabolic curve. Okay, volume rate of flow is same through the path, therefore as the height of film decreases, the velocity has to increases. Okay, you can see when the height of film is increasing, velocity also increasing. Now you can see the journal bearing process at the startup. Okay, a shaft or the journal bearing, you can see the moment you can have the three figures. uh, this one will call as a bearing, and this one will call as a journal, and the eccentricity is nothing but the distance between the center, and you can see this one is the stationary journal, and the instead of starting you will be having this one, while running here you will be having this one. Okay, because of the eccentricity the wedge is maintained, lack of concentricity wedge is maintained. Now see the pressure distribution in the journal bearing, and you can see here the blue color is nothing but the shaft. Okay, and this one will call as the bearing, and this one and this one is nothing but the pressure distribution will be there. Maximum pressure is reached somewhere in between the inlet and outlet, mainly close to the outlet. You can see over here. You can see that tilting pad thrust bearings will be there. Here axial direction, number of tilting pads forming the wedges. You can see everywhere here wedges will be formed, and that one oil formation will take place. You can see tilting pad thrust bearing also. Here you can see the whatever the tilting pad here. Okay, this is a bearing plate, and this is a collar, and this is propeller, and this is a shaft. Actual loads from machine being driven in this case, thrust from the propeller gives the damping effect, will be giving the damping effect. Now you can see the what are the characteristics of the hydrodynamic lubrication. Fluid film at the point of minimum thickness decreases in thickness as the load increases. What it is trying to say, when the load increases, what we'll call fluid film thickness will be decreasing. Okay, as when applying the more load, what we'll call the thickness of the film will be decreasing. The pressure within the fluid mass increases. The pressure within the fluid mass increases as the film thickness decreases. Okay, when the load is increasing, Okay, film thickness decreases. When the film thickness is decreasing, pressure inside the mass will be increasing. Okay, now you can see here when load is increasing, you will see thickness will be decreasing. When thickness is decreasing, you can see pressure is increasing. These are the criterias will be there. Pressure within the fluid mass is greater at some point, approaching the minimum clearance, and lowest maximum clearance. Viscosity increases as pressure is increases. Viscosity increases as pressure is increases. All these are the consideration. And the film thickness at the point of minimum clearance increases with the use of more viscous fluids. With the same load, the pressure increases as the viscosity of fluid increases. With the given load and the fluid, the thickness of film will increase as speed is increased. Fluid friction increases as the viscosity of lubricant becomes greater. Okay, fluid friction increases as the viscosity of lubricant becomes increases. In simple, we will try to summarize what are the characteristics of the hydrodynamic lubrication. Hydrodynamic lubrication, you can see when the load is increasing, the thickness of the film will be decreasing, because when the load acts on the object, the fluid will be becomes narrower in between the surfaces. Because of that reason, thickness of the film will be decreasing. When the thickness of the film is decreasing, as a result of which pressure within the fluid will be increases. When the what we call pressure is increasing, viscosity also increases. These are the few characteristics of hydrodynamic lubrication. Now see here, hydrodynamic condition and the fluid velocity, and the hydrodynamic condition and the load. We can see fluid velocity depends upon the velocity of the journal or rider. Velocity of the journal or rider. Okay, fluid velocity increases with the relative velocity tend towards a decrease in the eccentricity of the journal bearing. Increase in velocity decreases the eccentricity of the journal bearing. This is accomplished by minimum film thickness. If the thickness is minimum, relative velocity will be increases. Okay. Now we will see hydrodynamic condition in the load criteria. Increase in load decreases minimum film thickness and also increases pressure within the mass to provide the contracting force. The pressure acts in all directions, hence it tends to squeeze the oil out of the ends of the bearing. Increase in pressure increases fluid viscosity. We already discussed in the previous slide also. When the load increases, what happens? And okay. Okay. What are the functions of the lubricating oil? Okay. The functions of the lubricating oil is to reduce the friction between the moving parts. Function is nothing but reducing the friction between the moving parts and to reduce the wear of moving parts as far as possible. Okay. It also acts as a cooling medium and it reduces the noise between the striking surfaces or contact surfaces. In some cases, it provides as a sealing action. Sealing it acts as a sealing agent in between the two surfaces. In some cases, it also provides cushioning effect, and in some cases, it also provides cleaning action. These are the basic primary functions of the lubricating oil, which are nothing but reducing the friction between the parts, reducing the wear between the parts, and minimizing the noise between the contact surfaces. And in some cases, it acts as a cooling medium, and in some cases, it provides cushioning effect, and in some cases, it provides cleaning action. Now we will try to see what are the requirements of a good lubricant. Good lubricant. Okay, viscosity is main criteria for a lubricant. a viscosity, high viscosity index is required. Petroleum lubricant oil will have the viscosity index of 100 and can be increased up to 120 to 130 by means of additives. Okay, a main criteria for a good lubricant is the viscosity. It should have the high viscosity index. Okay, for petroleum oil, viscosity index is 100 and it can be increased up to 120 to 130 by means of the additives. Okay, second requirement is the physically stable. Stability is required and the chemical stability is required. Physical stability is nothing but when you apply the loads and that one loads and the forces, in such cases it should be stable, and the chemical stability is required, and the resistance against corrosion is required. When we are using the lubricant, it should resist against the corrosion. Flash point should be very high for the lubricant, and cleanliness is also required, and the resistance against extreme pressure is required. Following are the considerations which are good for required for the what we'll call the a good lubricant. Viscosity is required, physical stability, chemical stability, high resistance against the corrosion, and the flash point should be high, and the cleanliness and the resistance against extreme pressure is also required. Now you can see the various type of the lubricants. You can see animal oils, okay, vegetable oils, mineral oils, and the synthetic lubricants, grease, and the solid lubricants such as the graphite. Okay, there are many types of lubricant. The lubricants are available in the nature, and some synthetic lubricants also there. Okay, natural lubricants are nothing but animal oils which are extracted from the animals, and the vegetable oils which are extracted from the vegetable, and the mineral oils which are taken away from the earth ore, and the synthetic lubricants are nothing but the lubricants which are created by mixing different substances. Okay, and the greases is nothing but a semi-liquid lubricant, and the solid lubricants is nothing but the graphite. In lubricants, viscosity rating plays a major role. According to the Society of Automotive Engineers, you will be having SAE 0, 5, 10, 20, 25. Okay, these ratings are used in the winter season, whereas in summer season you can use oil 10, 15, 20, 30, 40. SA, we will call as a SA 30 oil, SA 40 oil, SA 50 oil. 0 to 25 can be used in the winter season, and 10 to 300 can be used in summer use applications. Okay, multigrade oils also available, 10W by 30, like that you can see. Whatever the engine oils normally used in our automobiles is nothing but 10W by 30. These are called as a multigrade oils. Oil additives. Oil additives are nothing but the chemical substance which are added to the lubricating oil either to reinforce some of its natural properties or to provide it with certain new properties which does not possess originally. Okay, oil additives are nothing but the substances which are added to the lubricating oil to get the desired and the expected properties in the lubricant. Okay, now you can see oxidation inhibitors is nothing but amines, sulfides, and the phenols with the metals like tin, zinc, or barium. If we are adding these substances, and it provides the oxidation inhibitors, and corrosion inhibitors are nothing but oxidation inhibitors with metal salts. If the metal salts are added along with the oxidation inhibitor, then it will be having the corrosion inhibitors. Okay, detergent, high temperature deposits, gums, and the varnish and dispersions. Low temperature deposits are cold sludge. Anti-scuff additives to polish moving parts like piston, cylinder walls, and the cams, etc. Viscosity index improvers. Anti-foaming additives are nothing but polyorganosiloxanes. Okay, polyorganosiloxanes will be there. Here, all these are oil additives will improve the performance of the lubricating oil in different aspects. Based upon the application, based upon the required condition, we will add the respective additives. What are the parts which are generally requires lubrication? The parts which are generally required lubrications are main crankshaft bearing, big end bearings, gudgeon pin bearings, piston rings and cylinder, timing gear, camshaft and the camshaft bearing, valve mechanism and the electrical equipment. These are the general parts which are in the automobile which basically requires the lubrication. Lubricating system, you can see here, you can having the rocker arms, and the rocker shaft, and the engine walls will be there. You can see the cylinder heads, okay, and the camshaft, oil gauge, oil filter, and the crankshaft, timing action tensile, oil galleries, and the driving shaft power system, and the oil sump you can see, and the floating intake and the screen. Here the oil will be taken from the sump, and the pump circulates the oil. From the oil it will go to the engine parts and the lubrication will take place. The purpose of lubrication. Generally, why lubrication is required? In some cases, lubrication reduces the friction by creating the thin film between the moving parts. In some cases, it has acts as a friction reducer. In some cases, like sealing, it also acts as a seal. The oil helps from a gas tight seal between the piston rings and the cylinder valves. Here it reduces the gap between the piston and the walls, and it acts as a sealing agent. And sometimes lubrication is also act as a cleaning agent. As lubricant, it circulates through the engine. The oil pick up the metal particles and the carbon and bring them back to the pan. Okay, nothing but lubricant is acting as a cleaning agent. Sometimes it acts as a cooling agent, lubricant. It pick up the heat when moving through the engine, then drops to the cooler oil pan and giving some of this heat. Okay. Sometimes it act as a shock absorber when the heavy loads are imposed on the bearings. The oil helps to cushion the load. Okay. Sometimes it act as a contaminants absorbent. The additives in the oil helps to absorbing the contaminant that enter the lubricating system. Okay. In some cases it has lubricant act as a lubricant. In some cases it act as a sealing agent and cleaning agent, sometimes cooling agent, and sometimes shock absorbing agent, and it also absorb the contaminants in that one. Now you can see the some basic references which are considered in this topic. You can see the handbook of lubrication and tri-volume of volume second volume, and the lubrication of fundamental revised and explained it by Don Miro, Martin Webster, and the Deschner. And you can also visit the site www.coolcraftpublishing.com textbook on lubricants and lubrication reason. And you can also visit what we'll call automotive lubricant reference book by Arthur J. Keynes, Roger F. Haycock, and John Hiller. Okay, this is about the module 3, end of the unit, and thank you.
Like, share and subscribe. Hit the bell icon for more updates.